Hello, welcome to our lesson on polar coordinates. This is our first day of the unit in polar coordinates. As you can see, polar coordinates allow us to graph much different graphs than we graph with our old coordinate system. Our old coordinate system we call rectangular coordinates, or sometimes we call them Cartesian coordinates after Rene Descartes. Uh, Rectangular coordinates use horizontal and vertical distances to direct the distances from the origin. We would say we move 3 to the right and 4 up to get to a certain location. Now polar coordinates, they use distances and directions to identify a point. So they'll say the point is 5 away from the origin at 50 degrees. So what that means is you go out 5 units at 50 degrees up, so that is 5, and this is 50 degrees up. We have a fixed point called a pole. I should pull this up, and my O. This fixed point is called a pole, right here. The ray starting at O is called the polar axis. So this is our polar axis. A point P, I can put out point P, is defined as its radius, or r being the distance from O to P, and the angle from the polar axis. So this distance is r, and this angle is our theta. So if we wanted to plot the point 430, what I would do is take out and try to get equal distances here. That one wasn't the best, but make it a little bigger. So we're going to go the distance of 4, and we're going to go in the direction of 30 degrees. 30 degrees is about right here. So I'm grabbing everything but what I want to grab. And there we go. So if we're going to go 4 units out, that's 1, 2, 3, 4 in the direction of 30 degrees. So that's right there. So that point is 430 degrees. Oh, there's one thing I forgot at the bottom. What if I wanted the point 4,390? 390 is 30 plus 360, and that would get us right back to the same location. So we could write this as 4,390 also. They're in the same exact location. Now if we add in some negatives, negative 430 means we have our, I'll do that back on this. So if I do negative 430, here's my 30 degrees, and instead of going this way 4, I go in the exact opposite direction. So 1, 2, 3, 4 out here is going to be negative 430. Now let's plot some points. This is a graph in polar coordinates. If I want to graph the point 3, 150, well, we know straight across is 180 degrees. If we do every other, this would be 30, 60, 90, 120, 150. So 3, we count this first one. 1, 2, 3. So this would be our point A. Point B is 270, negative 4. So negative 4 would be going up. 1, 2, 3, 4. That's B. C is 2, negative 135. So negative 135, this is negative 30, negative 60, negative 90, negative 120. Negative 135 would be 15 over, which would be right there. So we're going to go 2 out in that direction and label that point C. Now take a second and try to plot these. Pause the video. Now, these are in radians, so that's pi. So if I wanted to do d, we needed pi over 4. So if I cut pi in half, it would be here. If I cut this in half, it would be right there. So if I go in that direction 4, 1, 2, 3, 4, that's my d. 7 pi over 6 is 1/6 past pi. So 7 pi over 6 would be here. And instead of going in this direction 3, we're going to go back 1, 2, 3. And that point is E. F, we go 7 in the direction of pi. Pi is just straight across. 1, 2, 3, 4, 5, 6, 7. That's my F. Now, polar versus rectangular coordinates. If I have a point, let's find the point 1, 7. That means I go to the right 1, up 7, and that's my point 1, 7. Now, if I want to find this in polar coordinates, what I'm first concerned about is this distance. So we need to find that distance. Well, we can use Pythagorean theorem and say 1 squared plus 7 squared is equal to c squared, or 1 plus 49 is equal to c squared, or 50. Square root both sides. Oop, I don't need a square there anymore. And now we can take a square root of 25 out. So this would be 5 times the square root of 2. So that's my distance from the origin. Now I need to find out my theta. So my theta I can find out by using tangent, because this is opposite over adjacent. So if I say the tangent of theta is 7 over 1, we just have to take out our trusty calculator. Remember to make sure your calculator is in degree mode. And then we just need to do second tangent of 7 over 1, which is 7. And we'll find out that that angle is 81.86 degrees. So in rectangular coordinates, it's 1, 7. In polar coordinates, it's 5 root 2. What was it again? 81.8, I believe. 8.6, so 8.7. So this would be the polar coordinates, and this would be the rectangular coordinates. Now, first I'm going to give you some easier ones where it's trig exact values. We could do all of these without a calculator. So pause the video, take a minute, figure these out in rectangular coordinates. Now I'm going to go through these. 360 degrees. 60 degrees is there. If this is 3, then this side would be 1.5, this would be 1.5 root 3. So my rectangular coordinates would be 1.5 to the right, 1.5 root 3. If I would do this with this next one, 1 negative 3 pi over 4. Negative 3 pi over 4 is going to be down here. If this distance is 1, this would be 1 over root 2 because this is 45, 45, 90. 1 over root 2 is the same thing as root 2 over 2 because we have to rationalize the denominator. So we go to the left root 2 over 2, and we go down root 2 over 2. Finally, our last one, which is probably the easiest. You don't even have to figure anything out, because pi over 2 is right up here. If we just go up 5, that point is 0, 5. Now find each of these points in polar coordinates, and then find the rectangular coordinates for each point. So this point down here, A, is 1, 2, 3, 4, 5, 6, 7, 8, 9. And if this is 180 degrees, this is 210, this is 225. B is, if this is 90, add 30 to it to be 120, and it's up 1, 2, 3, 4, 120. C is 1, 2, 3, 4, 5 at 270. And D is 1, 2, 3, 4 at 330. So to find the polar coordinates for each of these points, at A, this is a 45, 45, 90. So if this distance is 9, you'd have to divide by the square root of 2 to get each of these sides, which we could rationalize to be 9 root 2 over 2. So that would be negative 9 root 2 over 2 and down 9 root 2 over 2. For 120, now it's a 30, 60, 90. So I'm going 2 to the left and 2 root 3 up. So 2 to the left, 2 root 3 up. 5, 270 is just the point 0, negative 5. And 4, 330 is another 30, 60, 90. If this is 4, it's 2 root 3 and then down 2. So it's 2 root 3 down 2. Now going from rectangular to polar, if we go 2 to the right and 2 down, this hypotenuse is 2 root 2. So we have 2 root 2, and the degrees is going to be 315, because this would be 45. 360 minus 45 gives us 315. Negative 4 is 0. Over here, that's 4 at the angle of pi. 3, 4. We go 3 to the right, 4 up. So my hypotenuse is 5. So that's my R value. To find my theta, I have to do the inverse tan of 4 over 3. So I'll take out my calculator. The inverse tan of 4 over 3 will give us 53.13 degrees. And this one, we go 1 to the left, root 3 up. My hypotenuse is going to be 2. So my R value is 2. This is a 60-degree angle, so it'll be 120 degrees from the initial side. All right, and that is your first day of polar coordinates.